Zeno of Elea stands out as a significant figure in pre-Socratic philosophy. He was born around 495 BCE in Elea, a Greek colony in southern Italy. Zeno was a devoted student of Parmenides, a philosopher known for his radical monism. Parmenides argued that reality is a single, unchanging, and indivisible entity. Zeno, fiercely loyal to his mentor, dedicated his life to defending Parmenides' views from criticism. Zeno's philosophical strategy differed significantly from his contemporaries. Instead of constructing elaborate systems of thought, Zeno employed a unique and potent tool, the paradox. Paradoxes are seemingly contradictory arguments that, upon closer examination, reveal profound truths. Zeno masterfully crafted these logical puzzles to expose the inconsistencies and absurdities that arose from opposing Parmenides' monism. By highlighting the contradictions inherent in the belief of a plurality of beings and the reality of motion, Zeno sought to indirectly prove the validity of Parmenides' philosophy. Zeno's paradoxes were more than just clever arguments. They were powerful critiques of common sense and established beliefs. His work forced other philosophers to confront the limitations of human understanding and the paradoxical nature of reality. While we possess limited biographical information about Zeno, his philosophical contributions, primarily his famous paradoxes, cemented his place as a central figure in the history of Western thought. His work continues to challenge and inspire philosophers and mathematicians even today, proving the enduring power of his logic and the enduring mystery of the universe he sought to understand. Zeno's paradoxes are not mere logical tricks, but carefully constructed arguments designed to defend Parmenides' monism. Parmenides argued that reality is a single, unchanging entity, seemingly contradicting the everyday experience of a world filled with diverse objects and constant motion. Zeno's brilliance lay in demonstrating that accepting the opposite view, that of plurality and change, leads to logical inconsistencies and paradoxes. Zeno's paradoxes aim to demonstrate that assuming the existence of plurality and motion as fundamental aspects of reality ultimately results in contradictions. By highlighting these contradictions, Zeno sought to indirectly prove the validity of Parmenides' monistic view. If the belief in a multitude of things and the reality of motion leads to absurdity, then the only logical conclusion, according to Zeno, is that Parmenides' concept of a singular, unchanging reality must be true. Zeno's paradoxes, however, extend beyond merely defending Parmenides. They expose the limitations of human understanding, particularly concerning the infinitely small and the infinitely large. The paradoxes challenge our intuitive grasp of space, time, and motion, forcing us to confront the counterintuitive implications of dividing these concepts endlessly. In doing so, Zeno's work laid the groundwork for the development of mathematics and physics, fields that grapple with infinity and continuity in profound ways. The paradox of Achilles and the tortoise is perhaps Zeno's most famous and enduring puzzle. In this paradox, the swift warrior Achilles agrees to a race with the tortoise, granting the tortoise a head start. Zeno argues that Achilles, despite his superior speed, can never overtake the tortoise. Zeno's reasoning hinges on the concept of infinite divisibility. He posits that for Achilles to overtake the tortoise, he must first reach the point where the tortoise started. However, in the time it takes Achilles to reach that point, the tortoise, still moving, will have advanced to a new position. Achilles must then cover this new distance, but by the time he does so, the tortoise will have moved again, and so on ad infinitum. The paradox lies in the seemingly absurd conclusion that Achilles, despite his speed, will never surpass the tortoise. He is eternally destined to close the distance between them without ever overtaking his opponent. This counterintuitive conclusion arises from the assumption that any finite distance can be divided into an infinite number of ever smaller segments. The paradox highlights the challenge of reconciling our intuitive understanding of motion with the concept of infinite divisibility. The dichotomy paradox closely resembles the paradox of Achilles and the tortoise, yet it approaches the problem of motion from a slightly different angle. This paradox focuses on the challenge of traversing any finite distance when considering the infinite divisibility of space. Zeno argues that before a runner can reach their destination, they must first cover half the distance. However, before covering that half, they must first cover half of that half, and so on, ad infinitum. The runner is perpetually trapped in a cycle of having to reach the midpoint of an ever-shrinking distance. The paradox arises from the seemingly absurd conclusion that the runner can never begin their journey. The dichotomy paradox, like the paradox of Achilles and the tortoise, highlights the conceptual difficulties that arise when we attempt to reconcile our intuitive understanding of motion with the infinite divisibility of space. It challenges our ability to comprehend how motion is possible if each step forward can be infinitely subdivided into smaller and smaller steps. Section 5. The arrow paradox times illusions. Zeno's arrow. Paradox shifts the focus from the divisibility of space to the nature of time and motion. This paradox posits that an arrow in flight is, at every instant, at rest. Zeno argues that at any given moment, the arrow occupies a space equal to its own size. Since the arrow is not moving within this space, it is, in that moment, at rest. If the arrow is at rest at every instant and time is composed of a series of instants, then the arrow is never in motion. This conclusion, of course, contradicts our everyday experience of seeing arrows fly. The paradox arises from the attempt to define motion as a series of static states. The arrow paradox challenges our understanding of time as a series of discrete moments. It suggests that our perception of motion may be an illusion, a continuous flow rather than a sequence of static positions. This paradox has profound implications for how we understand the nature of time, motion, and the relationship between the two. Section 6. The paradox of plurality, one or many. While the previous paradoxes primarily address motion, the paradox of plurality targets the very concept of a plurality of beings, striking at the heart of Parmenides' monism. Zeno argues that if there were a plurality of things, the universe would be both limited and unlimited, leading to a contradiction. If things are discrete and divisible, as the concept of plurality suggests, then there must be an infinite number of these things. This leads to the universe being infinitely large. However, if these infinitely many things are to exist within a single universe, the universe must also be limited. The paradox of plurality highlights the difficulty of reconciling the concepts of unity and plurality, finitude and infinity. It challenges our understanding of the fundamental nature of reality. Is it ultimately one indivisible whole, as Parmenides believed, or is it composed of a multitude of distinct entities? Section 7. Ancient and modern resolutions wrestling with Zeno. Zeno's paradoxes have captivated and confounded thinkers for centuries, prompting numerous attempts to resolve them. Aristotle, for instance, argued that Zeno's paradoxes stemmed from a misunderstanding of infinity. He proposed that infinity is not something that can be traversed or completed, but rather a potential that is never fully realized. The development of calculus in the 17th century offered a powerful tool for addressing Zeno's paradoxes. Calculus provided a mathematical framework for dealing with infinite series and infinitesimal quantities. It demonstrated that an infinite series can indeed have a finite sum, resolving the apparent contradiction in the paradoxes of motion. Modern physics has also contributed to our understanding of Zeno's paradoxes. Quantum mechanics, with its concept of quantized energy levels, suggests that space and time may not be infinitely divisible, challenging a fundamental assumption underlying Zeno's arguments. Despite these attempts at resolution, Zeno's paradoxes retain their power to provoke philosophical and scientific debate. They serve as a reminder of the limitations of human understanding and the paradoxical nature of reality. Section 8. Zeno's enduring legacy. A challenge to thought. Zeno of Elea's paradoxes, though formulated over 2 millennia ago, continue to resonate deeply within contemporary thought. His work has left an indelible mark on the fields of philosophy, mathematics, and physics, challenging our understanding of space, time, motion, and the nature of reality itself. Zeno's paradoxes forced philosophers to confront the limitations of human intuition and the counterintuitive implications of concepts like infinity and continuity. His work laid the groundwork for the development of calculus, a branch of mathematics essential for understanding change and motion. In physics, Zeno's paradoxes have found renewed relevance in the development of quantum mechanics, which challenges the classical view of a continuous and infinitely divisible universe. They serve as a reminder that our understanding of the universe is constantly evolving, and seemingly intractable paradoxes can lead to profound scientific breakthroughs. Zeno's enduring legacy lies in his ability to pose questions that transcend his time, questions that continue to fascinate and challenge us today. His paradoxes are not merely intellectual curiosities, but rather profound meditations on the nature of reality and the limits of human comprehension.